Hello students, this is our 6th video class on quick revision series on electrostatics. So far, we have solved about 25 number of problems. All problems are unique and interesting. So today also we are going to add few more interesting problems on electrostatics in this revision series, 6th revision series. So for your better understanding, you may refer the following books: The Concept of Physics, very popular book you know. Then books by D.C. Pandey. Then GRB books on physics and IIT-JEE. So I am D.N.Thatoi. Welcome you all to my new YouTube channel Physics Sketch. Let us start the problem. So as shown in the figure, this is our first problem today. So in this problem, there are three charges having charge Q each and mass M. So in this figure, there are three charges Q, Q, Q. All charges are positive and same magnitude. Masses are M, M, M. They are placed in space with a separation L, equilateral triangle. So due to the mutual force of interaction, so they will be going further away and find out the ultimate speed of the charges in this system. So now you know. So let us assume that electric force is stronger than magnetic force. So now assumption is electric force, electrostatic force is greater than the gravitational force. Greater than the gravitational force. That is what we have first assumed. So if the electrostatic force is greater than gravitational force, there will be a repulsion among them. And also due to the gravitational force, you know, gravitational force means each mass will attract each other. Since the electrostatic force is more, gradually the masses will be moved further away. Then ultimately they will be going to the space and the separation between them is large. So to solve this problem, then you have to apply the energy conservation principle. That is that the total energy initial is equal to total energy final, because you know gravitational field as well as electric field both are conservative. Conservative means there the work done is independent of the path. So we can apply here total energy initial is equal to total energy final. So total energy initial, this is the initial state. In the initial state, total energy is equal to only potential energy, that is equal to potential energy gravitation plus potential energy electric. So now initially no kinetic. Now at the when they will be farthest away from this space. So now in this case, so there is no potential energy. So potential energy gravitation will be 0. Then potential energy electric field, that is also 0, because they will be far away from each other. And the only kinetic energy will be present now in this space. So you have to find out what is the ultimate velocity in this space. Then what is the gravitational energy? So gravitational energy between these two masses, that is equal to minus g m1 into m2 m into m divided by distance between them is L. So this is g mm by L, g mm by L, g mm by L. So because there are three pairs, so total energy will be g mm by L. This is the total gravitational potential energy initial. So what is the electrical potential energy? Electrical potential is equal to A, so Q into Q divided by R. R is the distance between them. Then again how many pair? K Q Q by R, K Q Q by R, K Q Q by R. So total distance is again this. So total gravitational potential energy, total electrical potential energy, this is the initial. Then what about the final? So final, no gravitation, no electric, because charges will be far away from each other in this space. So only kinetic. So kinetic energy is equal to half mv square plus half mv square. There are three charges, three masses. There will be 3 by 2 mv square. Then from this we can find out that is equal to, now let us find that is equal to 3 by L common. that is k q square, that is k into q square minus g into m square, gravitational constant mass is equal to 3 by 2 m into v square. Then the 3 is cancelled out. Then ultimate velocity in this space is how much? The ultimate velocity is equal to 2 will be coming to this part, that is equal to 2 by L. The m will come to this side, 2 by m into L. It is equal to k q square by g m square root over. This is the ultimate velocity. So please note down. This is ultimate velocity. So when they will be far away from each other. So again you can say that if the electric force or the electric field is stronger in compared to gravitation, then you can freeze up the gravitational force or gravitational effect. Then you can get the velocity, and that velocity will be this much. 2 k q square by ml will be the velocity in this case. So anyway, this is the question number 1. Now come to question number 2. So again, the question number 2 is again this is important question. Interesting also. Look here. In the question number 2 is based on the dipole, net dipole moment of a system. So now let us take the charge system like this. So now this is the origin. So a charge is kept here. This distance is equal to 3 and 0. So this distance is 3 and 0. The coordinate system. This is equal to 3 and 0. And charge is kept here is equal to 1 coulomb. This is 1 coulomb. So another charge is kept here. This coordinate is equal to 0 and 2. And charge is equal to 2 coulomb. Plus 2 coulomb plus 1 coulomb. And at the origin, a charge is given here, that is equal to minus 3 coulomb. So question is, find out the net dipole moment of the system. Find out net dipole moment of the system. Very interesting problem. Then how to get the dipole moment? Now come to the problem here. So you know dipole moment means when two equal and opposite charges. If this is a charge, this is equal to minus q. This is another charge, same value plus q. Then there is a dipole moment, always from negative charge to positive charge. And dipole moment, you know the product of the charge and the distance between them. If the distance between them is L, then dipole moment is equal to Q into L. If the distance between these two charges is L, then dipole moment is a vector quantity. It is always from negative charge to positive charge and product of the charge and the distance between them. So now in this case, how to model dipole moment? So out of the total minus 3 coulomb, so you say minus 3 is equal to minus 1 coulomb. So you write this minus 3 is minus 1 coulomb, another is minus 2 coulomb. So 3 coulomb is minus 3 coulomb is divided into minus 1 and minus 2. So minus 1 and plus 1, they will constitute a dipole. Let the dipole moment is P1. And minus 2 and plus 1, they will constitute a dipole. Let the dipole moment is P2. Now dipole moment is coming. So one dipole is from dipole moment is always from negative to positive. So here negative charge is minus 1 coulomb, positive charge is 1 coulomb. Distance between them is equal to 3 meters. Now write down here. So now in one dipole moment is to write the dipole moment is equal to P1, and the P1 is the product of the charge. Charge is 1. Separation between them is equal to 3 because this distance is 3. That is equal to 3. That is equal to 3 coulomb into meter. Because dipole moment is the product of the charge and distance, that is equal to coulomb into meter. Then another dipole moment P2. So P2 will be upward. That is equal to P2. Then what is the P2? Now P2 is the dipole moment. That is the product of the charge and the distance between them. What is the charge? Charge is equal to minus 2. What is the distance between them? 2. So the again dipole moment is equal to how much? This is equal to 2 into 2. That is equal to 4 coulomb into meter. So now there are two dipoles. One dipole is 4, another dipole is 3. So let us make it this is 3, smaller one. So net dipole moment is equal to the vector sum. So this is the P net. So the net dipole moment is how much? Now the net dipole moment magnitude is equal to this magnitude is 3, this magnitude is 4. Net dipole moment is equal to 3 square plus 4 square root over, that is equal to 5 coulomb into meter. Coulomb into meter. Capital letter C, small m. So net dipole moment is along this direction and this is 5 coulomb meter. This is the question number 2. Now come to question number 3. The question number 3 is based on the electric flux. The question number 3 is based on the electric flux. The question is given, there is a cube. The question is given, there is a cube. The dimension of the cube is equal to, this is a cube. This is a cube of sides A. This is a cube. So inside the cube there is a charge conductor. The length of the conductor is very large and straight. There is inside the cube you just keep a charge conductor. Now this is a charge conductor, very long charge conductor having charge lambda coulomb per meter. That is lambda coulomb per meter. This is the charge of the conductor, straight conductor. It is a straight conductor. It is a straight conductor. So question is, if this conductor will be placed inside the cube, find out the net flux linked to the cube. So find the net flux linked to the cube if this conductor is placed inside the conductor, inside the cube. That is your question. What is the maximum flux linked to the question? So question is, so find maximum flux, maximum electric flux linked to cube. That is your question. Now you know that what is the definition of the flux? You know the flux is defined as, so you know the flux is defined as, electric flux E is defined as what is the charge divided by what is the permittivity. So now this is the cube. Inside the cube what is the charge? So find out, then divide epsilon 0, that is the electric flux. So electric flux will be maximum. It will be maximum if the charge is maximum. And charge, you know, charge is defined as lambda into length, lambda into L. Then lambda L is equal to maximum. Then charge will be maximum divided by epsilon 0. Simple statements. So now question is, you have to find out the flux. So we know flux is defined as charge by permittivity. So if charge is maximum, then flux will be maximum. So charge depends upon lambda into L because the charge carries on a line. Lambda, that is coulomb per meter. So lambda into L. So now if lambda L is maximum, then flux will be maximum. Then what is the maximum length of the conductor can be accommodated inside the cube? So obviously, if the conductor is placed along the body diagonal of the cube, now this is the maximum length, and this maximum length is, you know, root 3 into A. For a cube, the body diagonal, this is the length, maximum length. So this is the maximum length, L max, inside the cube. The maximum length inside the cube is the body diagonal. For a cube, the body diagonal is L square plus L square plus L square root over, that is equal to root 3A. Now come to the problem here, that is equal to lambda, L is equal to root 3A divided by epsilon 0. So now answer to the problem is, electric field maximum is equal to, so root 3 lambda A divided by epsilon 0. So this is the answer to the question number 3. This is the question number 3 and this is the answer. Nice question. Nice question. So only thing that you have to find out what is the maximum. How to maximize. This is the concept. Now come to question number 4. In the question number 4, so question number 4 is given, there are two spheres. Okay, so please note down, the question number 4 is given, there are two spheres. So this is a sphere, the radius is a. This is another sphere, radius is a, but it carries charge 2q, it carries charge minus q, and the distance between them is r. Then find out the force between them. Let us find out the force between them. The force between them is equal to how much? K. This is force between them is magnitude. That magnitude of the force. The magnitude of the force is equal to K, 2q, one is q. So another charge is q. Magnitude means only magnitude divided by r square. So the magnitude of the force is equal to 2k q square by r square. This is the force between them. So again I am explaining. There are two charges, spherical charges, and both the spheres have radius a. So this is charge 2q, this is charge minus q. Distance between them is r. The force between them is equal to k q1 q2 by r square Coulomb's law. This is the force that we know. Second case, what we are going to do? So these two charges will be temporarily connected by a conductor. Then the conductor is removed. These two charges will be temporarily connected by a conductor. Now please listen carefully. These two spheres will be temporarily connected by a conductor, thin conductor. Very thin conductor. So this is connected by a thin conductor temporarily. Then the conductor is removed. So what will happen? When the two spheres will be connected by a conductor, now since both the spheres have same radius, so they keep a same amount of charge. Then what is the total charge? So what is the total charge? The total charge between them is equal to 2q. This body has charge 2q. This body has charge q. So total charge is equal to q. So that total charge will be divided into half. So in the second case, so when they will be connected and this conductor will be replaced, now they will have charge q by 2, and the distance between them remain the same r. Then what is the new force? So now the new force in this case is equal to k, charges are q by 2, again q by 2, distance between them is r square. So the force is equal to k q square by 4 r square. This is the force of in the second case. Now our question is, what is the ratio of the initial force? This is initial figure, and what is the force in the second case? What is the ratio? So now we can say the ratio between the forces F1 and F2, the F1 magnitude divided by F2 magnitude is equal to, that is equal to k2kq by r square divided by kq square by 4r square. It is equal to 8:1. So now this is also a very important problem. When they will be connected and this conductor will be replaced, because they are of the same size, they will now keep same amount of charge. So now we add the charges, cross 2q minus q, total is coming q, that total will be divided into half. Then again apply Coulombic force, then get the new force. This is the first case force, this is the second case force, ratio is equal to 8:1. This is your fourth problem. Now come to the last problem of this series, that is the fifth problem. Let us solve it. Please note down. Now this is the last problem of this series. Now we are going to finish the series. So in this series, last problem given, the question is given like this. Interesting problem. Now this is a cube. Okay, this is a this capacitor, this is a capacitor, this is a capacitor, this is a capacitor. All are identical capacitors are connected up to infinite. This is a conductor. So they all are connected up to infinite. Now in between there is a capacitor. In between there is a capacitor. All the capacitors are same. C, capacitor C, and the system is continued up to infinite. It goes to infinite. So many capacitors. Question is, find out the net capacitance between the point A and B. Find out the net capacitance between the point A and B. How to get it? Now question is very simple. So now you will think this way. So now if I am coming from the right, so if up to this the capacitance is X, then up to this capacitance will be X. Up to this. So this one, up to this is X, then I will add one more set, the capacitance will be X, because when you add 1 with infinite or you subtract 1 from infinite, the capacitance remains the same. That is the concept we are using here. If so many capacitors up to this line, let's say the line is equal to A dash B dash. If up to A dash B dash net capacitance is X, then up to AB also the net capacitance will be X. That concept we are using here to solve the problem. So what is the next step? So you just follow what I am doing. So now what I have told, now from right up to this, if the net capacitance is X, now let us replace them. Let us replace them all by a capacitor, and the capacitor is X. Now all the capacitors to right of this point, if all are treated as X, then this is X, then this and this and this, again this will be again X. That is the question, and you will get the solution. So now let us solve the problem. So you know that these two capacitors are in parallel. What is the net capacitance? Net capacitance is equal to C plus X. Draw the diagram. Draw the diagram here. This is the A point. This is the A point. Then there is a capacitor, and this capacitor becomes how much? This is the B point. This is C, and this capacitor is C plus X. And these two are again series. So these two are parallel, C plus X. Again these two are series. When the two capacitors are series, now what is the resultant? The resultant across A and B. So the net capacitance between the point A and B is equal to how much? The series combination of these two. In series, you know, when two capacitors are in series, the answer is C1 C2 by C1 plus C2 when capacitors are in series. Then C1 is how much? C into C plus X divided by, so C plus X. So this is the net capacitance between A and B. Then what we have discussed? The net capacitance between A and B is also again X. The net capacitance between A and B is again X. So right, X is equal to, that is equal to C square plus Cx. C into C square into Cx divided by 2C plus X. Then cross multiply and solve for X. That will be your solution. Okay, let us complete the solution. Now, so let us cross multiply here. So it will be how much? That is equal to 2cx plus x square is equal to C square plus Cx. Then it is coming to be, so that is equal to x square, then plus Cx, x square plus Cx minus C square is equal to 0. So if this is the case, then I can say x is equal to minus b plus minus b square plus 4ac, 4 into c square root over divided by 2a. So now I am coming to this solution. Now the last line solution is only quadratic solution. So now the solution for x is equal to minus c plus minus root 5c divided by 2a. 2a means a is equal to here 1. that is equal to 2. Then if I will take negative, the capacitance will be negative, so negative cannot be taken. So the net capacitance will be, I have to take positive, that is equal to root 5 minus 1 into C divided by 2. This is the net capacitance between the points A and B. This is all our question, last question. I hope so you all have enjoyed the classes. Keep watching. So I will be back with a new topic, new subject, that is current and electricity in the next series. Thank you all.